Hello. This time I would like to work on cutoff points in the kanji database. So cutoff points indicate that that the previous kanji is sorted has a different sort key from the next kanji. So the sort key refers to the radical and residual stroke count, and the if the radical of so for example, here are the cutoff points in this column on the right, the third column. One indicates it's a cutoff. Well, zero indicates it's not a cutoff point, and non-zero indicates it is a cutoff point. So here's a cutoff point, and here's a cutoff point, and this is not one, it's three, but this is also a cutoff point. And so the cutoff point means that the previous character has a different radical or residual stroke count from the current character. So for instance here, we treat all one stroke radicals as the same radical. So this one has the radical of itself, which is just this single line, and this one also has a one stroke radical. So they have the same radical, but you can see that this one has two strokes and this one has one stroke. So over here, current you can see what we have here. We have 0, 1, 0, 0 as example cutoff points. I'm looking it over on the left here, and the this is what we store. This is an example of what we store just in this source file, and we don't really need the little letters here. The letters are redundant. Let's just delete that. So the cutoff point, this one is a cutoff point kanji. And so what we do currently is we just set the radical stroke count key to be monotonically increasing for every single character. And so this would be like x plus 1, x plus 2, x plus 3, x plus 4. But the thing is, we want to actually indicate that that this one is the same as this one, and not necessarily one different. And we do that. We're going to do that by looking at the cutoff point. And so the reason why we want to do this is because when we show the character, like the on-screen keyboard, I would like to cluster the characters in this manner. Let me paste this here. So I would like to say put a kind of pipe here or some other separator to indicate that these three characters have more residual strokes than this character. And in this example, these have two residual strokes each and a one stroke kanji. So all these have three strokes total. And this one has one stroke kanji and one residual stroke count. And so there ought to be a separator here. But the only way we can do the separator is if we actually have the key to compare them to, because there's no guarantee that in this list that the cutoff kanji will appear in it. So for example, if we have a list like this, well, the cutoff kanji is not there, and so we can't necessarily determine that we need to put this like that we need to put a separator here. If all we have is the cutoff kanji bit, then we don't really know that anything has changed. We can only know if something has changed if we store this this key, the one that increments when it reaches a cutoff point. So currently, to prove my point, we have we currently initialize the kanji database here, I believe. Yeah, here. And we just set the radical stroke count sort key to I, which is the index of the character in the database, and that is not ideal. So we are going to change this so that it will just increment it only if there's a cutoff point. So let's see what type do we use for cutoff points. new sort source kanji DPIH. Am I? Oh, I'm not changed to the right directory right now. Let's go to oh, you know what? I'm actually not in the right tmux window. Let me I don't want to change it at this point. Let me close the previous one. And so we're in new sort now. Let's go to source. Okay. All right, that's all fixed. So cutoff type is the like bit, so to speak, that indicates whether or not it's a cutoff kanji, and then the radso sort key. Excuse me. So this does not have to be a 32-bit character. This can just be a 16-bit character. Now that we're not going to increment it for every single kanji. Because if this were 16-bit and we did increment it for every single kanji, then that means we'd be limited to 65K, which actually is probably fine. But so I really should have made this as uint 16 from the start, but I didn't. So anyway, uint 16 type radso sort key 0. Okay. So now we're going to do what? We're going to say that if kanji I dot cutoff type, then we increment the radso sort key, right? And then we set it to set this here. And so this means we're going to be skipping 0 as a sort key, but that's fine. We don't really care about the absolute value of this sort key. Let's see if the test passed. Okay, the test did not pass because now we're sorting a little bit differently. So now let's look at the mixed up tests. So let's see. Let me do a unified diff. That's usually easier to read. Okay. So D7. Okay. So I see this is different from this. So D7 changed, and so this now is actually this one, D8. So that makes sense because these probably all have the same exact residual stroke count. So for example, yeah, because this one is based on the is not based on the ease of typing. It's just based on the order the kanji appears in the database. This input code mapping that it's generating. So so the thing is, I don't right now. It's like Q sorting it, and so it's going to pick a somewhat random sort order for this. And I think that I don't want to do that. I would rather use some key in addition to the radical stroke count sort key to give this a kind of consistent and deterministic ordering. Otherwise, the ordering is going to depend on some strangeness about like what the it's going to depend on like whether or not there's 31 characters before the kanji in the array or 32 as an example. And so we don't want to depend on that. We don't want to depend on kind of random chaotic stuff. So we'll have to choose another key to sort by after we sort by the stroke count. And another example, let's just look at another example. So here, this character means full, and now it's the next one, G5 instead of G4. So this is somewhat expected, I suppose. Let's see what other tests fail. We have free kanji keys output. That's strange. Oh yeah. Oh no. This one. Oh, we're running multi-threaded, so it's going to be a bit confusing. Okay. Uh, yeah, this is unfortunate because if I only run once, then I don't see what is. I can't see all the failing tests at once. If I run it single threaded, it doesn't show me all the failing tests. Well, this one doesn't show me all the failing tests either, but at least no, actually it did, because the tests are not dependent on each other, I suppose. Um, okay. I wonder if there's a way in make to just keep on going. Make do not stop on errors. How to continue after command fails on. To ignore errors in the command line, write a dash at the beginning of the line's text. That's not exactly what I want. K. Dash K, I think, is what I want. Okay. Let's try again. Okay. Good. So it failed. Let's see here. So it failed 1 test, 2 tests, 3 tests. Okay. And let's see, which one do we already check? Kanji database order test quiet. Here. Error. There's an error somewhere now. Okay. That's interesting. So, what is the other failure? Default mapping dot test out. We already checked that one. And last string contained test is what we didn't check, I guess. And the first test is the one we just did. Okay. So here's quite a lot. Okay. I suspect that this is different because the ordering of the kanji in the line is different. Because this is probably failing. Is this failing? What test is it failing, and what is it sorting on? This is the last rank contained test. So there's 2 sorting modes in last rank contained. Typical Kukiri kanji test dot test out. Okay. That's the first one, I guess. And this one, it does not. It passes S, which means which one does S mean? I have to open the implementation. S means sort each line by radical stroke count. Okay. Okay, so this is expected. Unfortunately, it's very hard to analyze this this output, but I guess we can do it. Like, we can pick a line here. Let's pick D, and make sure that the characters that are there are in both outputs. Well, the problem with that though is that I need to use a bash script at that point to split up the kanji into lines, which I don't want to do right now. I'd have to take a little bit to figure that out. So D is so let's take this. So maybe we can do it using an editor. Here, D. Say here. Okay, now I'm going to open a before file. Right? And I'll open a after file. Let's go to the after, okay? Or actually, this might be the I don't know if this is before or after, which we're looking at here. Let's see, where am I? Okay. Okay. It looks kind of different. So one problem is that the cutoff information is a little incomplete, and so while before it may have been sorting it properly, it might not sort it properly anymore because we were doing the sorting implicitly before. So that's a bit unfortunate, but we can fix it gradually. At least we don't have to fix it today. Okay, so I see the first four characters are the same. Now, okay, I'm trying to think about what is the easiest way to try this. Okay, so yeah, expected was on the, so before means what the expected output is. So this is the new output down here. So this is still the same. This character is still the last one, which means clean or pure. And it does look to me like whenever I look for a character, it looks like it's still in the same spot. Um, let's see here. How can we move this? So we could maybe separate it into bytes of 3 because each kanji is 3 bytes long in UTF-8, and that um, let's try a macro. So we're going to do QA to go to macro A, and we will say append, enter, append, enter, then escape, and then Q should stop recording. Okay. A. Okay, that worked. Oh, I may not even be using the macro feature. I can just repeat it in this manner with dot. All right. Okay, and then now we can do diff temp before and temp after. All right, so here this one is out and in at the same time. Oh, let's do a unified diff. This is always easier. Should be the default. Okay, so this is out and then in. That means river. And this one is out here, but it's added back here. This one is out here. Excuse me. But it's added back here. Okay, now let's go ahead and do a sort of these two. So we'll do diff sort temp before and sort temp after. Okay, good. They're the same. Now I'm kind of satisfied that that's safe. That this is safe to check in. Although, at least for this test, in the case of this test, I don't know why that other test was failing. One dash K. Let's check the other one. So I wonder, do we want to actually make this store the test output in a separate file now? That may make things easier. Let's go ahead and do that. So this last rank contain test here. Okay, typical cookie D. So this is the first test, was the one that's failing. And oh, but you know, we're not actually finished yet because we're still sorting by lots of different stuff. We're still not sorting as we want to. we want to sort by a deterministic method. So we'll do last rank contained rad. So how about we look for the rad sort key in the source code and see where it's actually being used for sorting. Check. I'm gonna look at all these instances and see what's going on. So here we sort. All right, this is in check kanji database order. So so here we're using it for sort. We may want to look at other places. We may want to move that into a utility method. Okay. DB. Let me make sure this comment is still correct. Okay, yeah, this is that's different. So I mean, yes, that's still correct. Now that's just saying that when we load it, we fill in the radso sort key later. We fill it in as we run startup. So now we can do 4064. So okay, that's fine. And kanji distribution, it looks like we use this field a lot. Radso sort key. First key. Okay. So this we may want to fix this. Here we're also using it to sort end line. End line. Yeah, this is to sort the output, so that's kind of more. This is just for the way it appears visually. I'm wondering if we're going to screw up the way the codes are assigned or something, but I don't think so because we shouldn't. The code. I'm wondering, like, is the way that the code, the first character in the code, going to be messed up now because we're now sorting by we're now sorting differently, but I don't think so, because that's basically what this first line is. It's figuring out what the first key is, and then it's checking the cutoff radso sort key. So every single cutoff should have a different one. So this should be totally fine. Every cutoff should have a different radso sort key based on the way we treat these values, because that's how we're assigning the rad stroke count sort keys. So this line is fine. This line is what we have to fix. We need to fix that. And auto pick cutoff. This sorts it by radicals. Yeah, this has to be fixed also. And that can probably use the same function to actually do the sorting. And this is cutoff. So this checks to see if we need to switch, if we need to start the next line in the output. And so this is this should be fine. This should not need to be changed. But this one and this one do. Kind of distribution auto pick cutoff. Oh no, this one also. This one, because we're sorting it. Well, we might be able to get away with not doing that because this is just picking. Populate non-hard coded. Yeah, I don't know if we need it here or not. Because this is picking the cutoff point automatically, and so it's going to be moving. So it's setting resorted so that it can go through all the kanji in the database based on the radical stroke count. And the point of that is to, yeah, this should be fine to keep it as it is. This should be fine because we're essentially just counting characters in each cutoff point, or rather in each line. No, no. We're counting characters. We're like adding characters to a database, to like a counting mechanism, which is the rank coverage mechanism. And rank coverage reset. Find best cutoff. Yeah. Now, what does find best cutoff do? It's here. So this one loops through the excuse me. This one loops through the kanji in the database in the new sorted order, which is sorted by the radical stroke count, and then it adds kanji here and add kanji. So it adds this here, and then it goes to cutoff type. If it's not a cutoff, then it continues. So if it's not a cutoff, then it's going to just kind of keep adding things over and over to this rank coverage system, which rank coverage is responsible for basically saying, hey, you need to do a cutoff here. The thing is, we're not really changing anything, and rank coverage doesn't care what order stuff is added to it. And cutoff type is only true for is if it's not true, then we're not even going to consider stopping anyway. And so this should be fine as it is here, because this line is responsible for like clustering things into things that have the same radical stroke count key. Okay, so anyway, that was a bit of a rabbit hole. Now, oopsie, didn't mean to do that. Okay. Now, the only thing that I'm a little hesitant about is that there was that failed check kanji database order test. That's going to have to be fixed. Check kanji database order test. Oops. I'm stuck. There we go. All right, check kanji database order test. Exit 0. Error. Okay. So it has an error, but it doesn't say which one. Match radical. Okay, so according to this, something is in the wrong order. Oh, so this check kanji database order really wants the characters to be in the correct order. So, but doesn't care if a cutoff is not set. So, for example, probably here we don't have, for this character, we don't have. Oops. Let me copy this and then paste. There. For this character, we may not have the cutoff point set properly. Well, actually, this looks like the cutoff point is set. Excuse me. So this one, these 4 characters here have a residual stroke kind of 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, here this one has 5. Then the next one has 1, 2, 3, 4, 5. Okay, so we go from 4 to 5, and that's probably what the problem is. We don't have the cutoff point set. So if we did this, I suspect that the test will start to pass. Let's only run this test. Check kanji database order test. Okay, make. All right, now we should have a failure that goes later. Yes, we're failing later. Now, I might have to fix this. So this is kind of a good exercise. This is fixing the cutoff points. 1, 2, 3, 4. Okay. Let me check to make sure this is correct. I'm going to check an online dictionary and make sure this is what I think it is. Okay, this is 7 strokes. So 1, 2, 3, 4, 5, 6, 7. So actually it counted it differently from how I counted it. So so let's do this. Let's make sure this is 7, even though this is more unambiguous. This should really be 7. Yeah, 7. Okay. So this one should actually be the cutoff point here, apparently. Let's try this again. Okay. Tmux doesn't really behave very well when I copy and paste these individual kanji characters. Okay, now what line are we on? We're on line 872. Okay, so these characters are going to have stroke counts that are harder to count manually. So I think what I'll do is I'll stop the video and fix all of these one by one. It's kind of tedious and maybe not all that interesting. So well, let's just see how far we get with doing a little bit more manually. Here, this is 14. The radical is this one, this thing at the top here, 14 and 14. So this was 14, 14, right? 15. 15 here. Okay. But the error was over here. So anyway, let's try setting this to cutoff point. This was 15. What about this? This one is also 15. This one is probably going to be 15. Yes. And the next one, I suppose, is a lot more. This looks like a whole lot more. 19. Okay. Okay. So this is 15. This was 14. All right. Let's try again. See how far we get. Okay, this is a different character we have a problem with now. Okay. And this is now on line 1036. Okay, so what I'll do is we're not going to finish that fast. It's tedious enough that I don't want to just show all this, and so I will actually, you know what? Maybe what we should do is we should pick this extra sort key first when we're no, I don't know. Check kanji database order. Now, was there anything in check kanji database order where we were sorting where we had to fix it? We have to sort differently because there were 3 places in the last rank contain command. So here you're sorting based on radical source. Okay, yeah. Check order. So here we probably do want to figure out a key, a proper key. Um, so let's just set the key, the figure out what key we want to use. Kanji database H. So we'll add a int rad so compare, and we'll have a struct kanji entry const a, and const b. All right. Sorts by radical plus stroke count, and then by rank, I suppose. Rank seems interesting. I would like to sort by the ranking rather than anything else, because that means that the sorting will be kind of informative to someone using, like looking at the order, and then by code point. All right, because the rank should really be different, but we have been assigning ranks manually when we add new characters, and so in that case, excuse me, right, so actually what we can do is we may never have to worry about anything after by rank. So let's just sort by the rest, but simply by radical stroke count and then by rank. So if a dash rad so sort key is not equal to b rad so sort key, then these are two uint16 types. Well, I'm a little bit hesitant about using subtraction to return the right value here. So if a dash rad so sort key is greater than dash rad so sort key, return. We'll use tertiary or ternary operators. So then 1, otherwise -1. Okay. Then we can do if a dash rank, I think it is, ranking not equal to b dash ranking, then say return a dash ranking is less than b dash ranking. True, we do 1, otherwise -1, because we want the lower ranks to come first. Okay. Lower ranks come first. Okay. Otherwise, we say bug need more deterministic comparison. Okay. So now we can go to check kanji database order. Now this is still going to fail, but I want to actually see where it fails. I mean, this is probably going to fail in different places in the checking the kanji database order, because we're still sorting by ratso sort key, but after that we're sorting by ranking. But that still means that this sort is kind of like arbitrary as far as the check kanji database order is concerned. So it's still going to fail, statistically speaking it should, but it's not necessarily going to fail in this character anymore. Although I think did we fix this character? I don't remember. Rad so comparison. Let's see, rad so sort key. Do rad so compare k a and k b. It's less than 0. All right, and now we do kanji distribution. We have this. We don't need to change that. And end line. Here we will fix this. rad. So compare ls dash ea and ls dash eb is less than 0. Okay, good. I like it when I don't have to wrap lines. Okay, just populate. Okay, this one doesn't have to be fixed. This one does not either, but this one does not either. Yeah, I don't think we have to fix anything else. Kanji distribution populates. Okay. I forget if this needs to be fixed or not. Cut off. So this determines if we end the line, right? And so sort key. Yeah, this does not have to be fixed. This is fine. Because this is comparing the character with actual things we know to be valid cutoff characters. And this one, excuse me. This one I don't think needs to be changed. Okay, oops. Database order. Use the wrong character in the ternary operator. Okay, now. Okay, this is different. Okay, still filling at the same one. That's interesting. I didn't expect that. Check kanji database order. So sorki. Okay. Let's see. All right, here. Okay, so I'm going to fix the rest of the places where we did not set the cutoff point off screen. So I'll stop the video now and I'll start recording again when I'm done with that. Okay, I finished adding the cutoff information, and what we'll do is we will commit the cutoff information only, and so kanji db.c. So we're going to stage this here, and here let's make this a little bit bigger. All right, so here, yes. Yes, some of these are very simple. See, I'm just adding cutoff bits to it. And here, I noticed that this was a switching to new radical, so I set the cutoff type properly. It used to be just a 1, now it's a 2. Here. Oh, so here we change the order. I usually have this practice of putting the most common, using the most common kanji as possible as the cutoff point, rather than just picking an arbitrary one. And that may not be necessary anymore because now we're starting to sort by the rank as well. But usually I do prefer to put the most common kanji first. So let's say yes, stage this. And here there's two new cutoff points. They just happen to be kind of close together in the database, and also sorting according to rank in this just because I noticed. And here we add 3 but take away 2, but in the next patch you'll see we take away the other one, so things are back in balance. And here same deal, setting the most common character as a cutoff point. And here same deal as before, here, and this was a messy one, but yeah, that's fine. We also made a new radical cutoff point. Oh, this might not be totally correct because, excuse me, because this is not a radical itself. Actually, I think it is. Radical. Let me check. 1, 2, 3, 4, 5, 6, 7, 7 strokes. Yeah, it is a radical. Okay, good. And so, okay, this is fine. This is fine. We're almost done. And this we're not going to do yet. So if we look at the cache or the stuff change for patching, so now we can, all right, we can commit this. And this is add missing cutoff bits to kanji database. All right. Great. So let's look at our tree. So this is GitHub, and we made a new commit on which is pending and not pushed yet, and it is to add the missing cutoff bits. Now, if we run make, we'll probably see that not as many tests are failing anymore. Just 2 should be failing. And I think what I want to do is kanji test out. For these tests which do not use a separate file for the output, I think I want to change that so they do use a separate file. So let's copy this test output to expected test out slash so here let's commit the changes. We're going to commit the changes, and we're going to go back to a sane state and then migrate the failing test to a separate file. So we're going to commit we'll say just stashing rad so sorting stuff, sorting key change. All right, now we want to go back to origin master, and we're going to start to move stuff into separate let's see, what do we want to move into a separate file? I want to move this to Gokugiri kanji test out dot test out. Okay. So what do we name it? We name it, so this, it looks like, should be the name of the test output file. Test last string contained, right? So we're going to say touch expected test out slash this. And then if we look in last string contained, let's go back to a sane size. Size, okay. Okay, setting the layout again. New sort, source, okay. Let's see here. I'm being a bit distracted by noises from the other room. Expect to test out. Okay, so this is a empty file, and Gokugiri kanji test last string contained test. So here we're going to remove this golden output from the file, delete, and we'll say expected is now 0, and that means that we will use a if, so this is all test driven, right? So that means now that we've set that flag, or we've removed that, now we can say if test cases test I dot expected. That means we use the inline source of the data. Otherwise, we do end test expected content in file. Right. And that should be all that we need to do. So we are here. Let's make. Okay. So now we can copy the file here. This is the expected, this is the actual, right? So we can copy the actual to expected test out slash last string contain test. All right, now make. So let's check out the, we'll call this new branch, move test out for putting test output in a separate file. Let's make it a better name, test out. It's a shorter name. Dash M, put test output in separate file. I'm doing this because I don't know how many times how many tests I want to put in a separate file until we see how much is failing. So, okay. So what we're going to do is we're going to probably rebase pending onto test out. So git rebase onto test out. Cutoff bits. Okay. Oh, but add missing cutoff bits does not really have to be separate, right? Add missing cutoff bits could be the base, but that's okay. Let's say git. Let's make sure that missing cutoff bits does not actually have any failing test. Oh, add missing cutoff bits does have failing test now that we've changed some stuff around. Okay, so I don't have time to finish this right now. We'll pause it. Okay, I'm back. Now, the deal is that add missing cutoff bits, which I thought would be self-contained and very simple, even that is changing the test output a little bit. And so we're going to put the test output in a separate file in the very first commit. Okay, so let's check out pending and rebase this onto test out. Okay, now I don't think we need test out anymore. And now we can go to commit to, and we'll say let's see how we're going to do this. So we do make, and we're going to fail one of these tests. Default mapping, typical Kogiri kanji test out. Okay, so cat expected out test out. Let's make sure that this is actually has the test output. Yes. Okay. So let's get it again. So we want to fix this test, and we will go ahead and copy the new test output into the expected test output. Copy expected test out to expected test out slash last string contain test. Okay. Now let's see what actually changed just by virtue of the fact that we added cutoff bits. So this is sorting by radical stroke count. So it may not even change the ergonomic version of the mapping. And I'm having trouble seeing where it's actually. Oh, is it just no? So the lines, the stuff at the end of the line is not changing. So this is different. No, this is the same, rather. Looks like everything is the same so far. Okay, oh, here, the first ones are different from before. Where do we get back in sync? Right here. Oh, I'm looking at the wrong line. Oops. So I'm trying to figure out where the lines actually differ, just so that it makes sense to me, like that it's changing. Here. Oh, huh? Yeah, here we go. These two characters look like they switch positions here. So I'm guessing that the next line also has like two characters that shifted position, and that will be reflected in the test, the default mapping test, the one that generates the non-ergonomic input mapping. Now let's just check down here and make sure that we get some similar results. Same. Here, these are different. These swap positions. Okay. So this has to be now part of the add missing cutoff bits change. So let's check out pending, and we're going to put it on top of commit this here. Dash fix up of number 2. Geez. Fix up number 2. Okay, git rebase dash I onto number 5. Okay. Now if we go to number commit 2, we'll see that we have one less failing test. Okay, the one that failed before is not the same one that's failing now. It's failing a later one in that same file. So now we want to move this one to a separate output file. Okay. So I'm going to go to number 4, check out 4, and I'll put that in a separate file as well. Oh, but I should probably put this on top of 3 because I had to make a change in the test driver logic. So in order for this to work, so I'll go to number 3, I guess. Just have a separate file. And we want to do automatically find Kugiri test out. Automatically. Kugiri hide kanji. Okay, this one. Here. Is that how we did it? We just did 0? Okay. So now touch test expected test out / last string contained automatically find Kugiri. Okay. And now we should make, and we'll see the okay. Now we can commit this cm-m and call it more test output in sep file. And now we have something like this. So we'll make a new branch called test out, and then we go to pending and git rebase onto test out. Right, now we can git rebase I dash d test out and git rebase I onto h5, and we move the this is now a fix up, which means it's combined with the previous commit. Now if we go to O3, we can make, and everything should work. Oh, no, that did not work. Automatically find Kugiri. What did I do? Did I not actually commit something? Did not actually commit what I wanted to. Cat l test ut slash last string contain a typical automatically find Kugiri. This has nothing inside of it. Okay, so that was a mistake. So that means we got to copy this file onto this file. Okay, and we're here. So I'm going to do the same thing, test out, and I will commit this as a fix-up of number 3, and then check out pending, get rebase onto test out. Then if we go to O3, we can make, and we should pass this time. Okay, good. Now, so we want to go to 2, I guess, and make, and then we can actually move these stuff. We can fix the test case. Let's get rid of test out. Let's fix this. Okay, so what changed? Okay, so it chose a different cutoff point. And I do remember changing around this one manually in the last commit, so that kind of makes sense. So we this is interesting because this means the layout is going to change even for the ergonomic version. And it looks like it chose a better, it chose like a, it chose one which did not have, which had a more optimal kind of an distribution of characters, because it did not deviate as much in the new output from the optimal like rank coverage pattern. So it should cover about up to rank 1250 in that code's range, right? And it used to cover only up to rank 1167. Now it's covering up rank to 1213. For the next line, the rank coverage got a little bit less. So I don't know. Maybe that's not. Well, yeah. It used to be -4 here, like it was off by 4 here and not off by any here, but now it's off by 2 and 2, so it's a little bit more even. Even though it's still not really close to optimal. Okay. So now we can check this, and we'll do fixed. We'll call this fixed test. Diff. All right, now we copy the actual test output to the expected test output file. Okay, good. And now we commit this as a fix-up to number 2. Now we check out pending and get rebase onto fixed test. All right. Now if we go, now we can get rid of fixed test. And now if we go to let's see, fixed test. So this will be a self-contained commit, more or less. Once we finish putting out in a separate file, then this will be a separate commit. Let's go to number 2 and make, and see how far it gets this time. Okay, this time it failed 2 tests. It failed last rank contain test again. Okay, so we want to move that into a separate file. Let's move 2 tests into a separate file at the same time, because we know which ones are failing, and it's annoying to do this in so many iterations. So let's go here. Let's open temp/tests, and we're going to write down the names of the tests that we want to fix. Oh, but this is already in a separate test. This is already in a separate file. So let's copy this. Let's fix this first. All right. Okay. So let's go be fixed test. Let's copy this. Change word copy. All right. And we're going to swap the order of arguments. Okay. Now we should have a fixed test. Huh? Looks like it didn't work. Fall method. Oh. Don't want the word diff there. Expected test out. Expected test out. Then we don't need the last thing. Okay. Now we can make. Now what is failing? Make map test ergonomic sort. Okay. So we will copy the actual output to the expected output. All right. Now let's make that, see if that works. Okay, now only last rank contained test is failing. This means this is we're going to have to put in a separate file too. So let's commit this and fix up equals, this is also a fix up of number 3. I'm missing cutoff bits. Okay, because lots of tests are failing because we added the extra cutoff bits, which is a little bit interesting. Let's pending get rebase onto fixed test. All right, get rid of fixed test. Now we're going to move this test into a separate file. String contained. Okay. So we want to go back to number 5 or check out. Yeah, I guess we can go to 6 too. Let's go to 5. Separate, we'll call it separate file in this new thing. And we're going to put showing count. Typically showing count. Okay, showing count. Let's reopen this. This is now going to be in a separate file. Right. So we're going to do a new file. Oh, maybe we can just copy. What is the name of the? Nah, it's annoying. I don't know if that's going to work. Last rank contained test. Okay, this touch. Okay. Now we can make this and we'll get an error because it doesn't have any output at all. All right. Now change this to a copy and we want to take this and put it as the last argument. All right. There we go. All right. That looks correct. Now if we make it, all the tests should pass. Right. So we're going to commit this. You see on the fix up equals h6. Okay. Now we check out pending rebase onto number 1. And we open 5 fix up. Now if we go to 2, we should be able to add this fix the test. So O2 and we make all right. And this is basically the same problem as before, but now we're showing the count, right? The number of kanji in each line. And so it's the same exact failure as the first one that we fixed. So we're going to copy, let's put this in a separate window. This makes it a little bit easier. Copy this to this. And now we call this GCM fix up on H4, right? Now we go to pending and get rebase onto number 1. So this time I avoided creating a new branch and deleting it later. Now if we make this, we'll almost, okay, we're getting closer. Hide kanji here. Okay. Now for this one, maybe it's not necessary to make a new file, but let's just be consistent. Yeah, because this does not have as much output for each for the test. It's a little bit easier to manage, but then again, fixing the output is annoying. So Yeah, let's fix this the right way. Automatically find. So this is the test we want to fix. Right. So let's go to our fix up our separating the test files series. Go to 6, and we are going to go ahead and edit last string contain test. Oops, test.c, and we want to go to hide kanji. Let's still find last string automatically find kugiri hide kanji. Okay. And I think that we're going to have to do it for the next test as well. The typical kugiri. But I don't think we fixed the typical kugiri ones. The one where yeah, we didn't have to fix this one, so we won't have to fix the next one. So I'm going to be very lazy and just change this one. This should be the last test we have to put in a separate file. Right? And we have, let's see. So we're down here. Now we're going to touch expected test out slash excuse me. Okay, now we make and copy. Oh, I didn't. Oh, I did test, not touch. There we go. Okay. Now we can copy this to this. Right. Good. And now we're down here. We can fix up number 8. And now we're at 1. So we'll rebase pending onto 1, onto H1. Okay. And now we're getting closer. So if we go down here, go to tests, let's see, fix up. I'm missing cutoff bits. 2, make. Okay. Now we need to fix this test. Right. B. Right. Oops. That didn't work. Copied the wrong stuff. Copy that. Okay. Now this is a fix-up of number 5. H5. Now check out pending and get rebase onto H1. All right, and here we go. So now we can go to back to 2 and make, and now the test pass. Okay, so now we have this self-contained commit and this self-contained commit, and let's rebase onto number 11. Right. Uh-oh. I'm missing cutoff bits. So I wasn't at the right commit, so now I need to cherry pick H3. Right. Now delete pending and check out pending. Create pending back here. Okay. Okay, good. Now if we go to 2 and we make, all the tests will pass. And 2 is now a actual self-contained commit where we're just fixing the test output, as well as adding the cutoff, fixing the cutoff characters. And if we go to 3, this is a self-contained commit where we're just moving stuff into a separate, moving test output in a separate file. And 1 is not finished yet. 1 is not quite there. So what is different? Yeah, this is where we're changing the sort order. So it's going to make things more difficult, I guess. But maybe this will not be that hard to analyze. Yeah, so this we analyzed already, right? We like checked a certain line and made sure that the kanji that were in it were the same. Okay, so maybe this is just fine to go ahead and commit. String contain test. Copy and then delete, then paste. See, I got confused now because my my system clipboard is not integrated with Tmux. Test expected test out. All right, now we can make now test mapping. Okay. Okay. I somehow copied too much stuff. So this is default mapping. So this is obviously going to be different. We expected that. So let's copy to delete word. Let's make that. See if any. All right, we're still having 2 failures each. Automatically find cookie. Okay, this is a little bit different, but that's basically expected because we moved we changed the sort order. I'm intrigued by the fact that this value changed, which is a kind of meaningless number, but it's the average number of the average rank range covered by each line. So let's yeah, this will take a little bit extra time to analyze, but maybe I should just go ahead and cop and update the commit. And because I doubt that we're going to find anything that we need to fix. So last string contain test. This is showing the test count. Yeah, this is going to be different as well. Because this is the same thing as before, but just showing the test count, showing the kanji number of kanji in each line. Copy. All right. See, I did it again. I used the wrong clipboard. All right. Still. Okay, make map test like rest. That's okay. All right, this is also changed, but we expect that. Okay, now we're down to 1 failure. Okay, this is different. And this is the ergonomic sort. But why? Because it's going to be sorting by rank anyway. So this should like not have as much of a drastic change in it. So this character moved down a little bit. This moved to a slightly different line. Well, this is probably because of the cutoff bits changing the coverage of each line, of each so for the range of characters which have the same first key as the input code, I call them lines. Just like in when you run last rank contained, every single line has a certain has all kanji that share the same first key in the code, and I call this a line. So anyway, so the line coverage changed for some of the lines. Hopefully not all of them. Yeah, not all of them. D and G changed, and if I'm reading this right, it didn't. Did it change every? I'm not sure if it changed every character, like 78906. 1, 2, 3, 4. Yeah, I guess it did change every like second key, uh, or every character in the line, every code in the line. It did change. Um, okay. Anyway, let's go ahead and commit all of this. Okay, now the test passed, and now we have a self-contained commit, and this can be an amend. All right. So I'm stashing it, but now it's actually kind of self-contained. So so I think what I should probably do is analyze the changes off screen. Oh, you know what I don't really like? This is Radso CMP, but I don't think we need the CMP. We just need a less than, like a less than predicate. We don't need CMP. So that will simplify things a little bit. So let's open kanji-db.h and radso less than checks if A is less than B. All right. And then I do kanji-db.c, radso less than. Okay. A, so return is less than. Okay. A greater than. All right. Okay, good. Okay, I was just interrupted for a second. Anyway, so let's see here. We were fixing the Radso CMP thing. So let's go to Radso CMP. Where is it used? It is used in check kanji-db order. Radso CMP less than. Okay. And it's also used in kanji distribution.c. Let's see. All right. Okay. Now let's run the tests. And they pass. So we can do this as an amend. Now, so I'm already pretty confident that this is safe, that we didn't really screw anything up here. But here I'm not quite so sure because we did change a lot of stuff. Let's look again. C1. Okay. So we're changing the sort scheme. And here now I really don't like this number. I think we need to get rid of it. This is not helpful because this increased, but it increased like too high. I really expected this to like always get closer to 1250, but it like gets farther away. I don't know if it's really a helpful number to have. So 1149, 1501, 1186. So let's reflect for a second about why this is changing, because to me it looks like the kanji there are still pretty good kanji to have in this place. So it's sorting by here. It's sorting by what is it sorting by? It must be sorting by frequency of use, because otherwise this would be, if it were sorting by radical stroke count, this would be before this, because these two have the same radical and this one has fewer strokes. So it's sorting by rank here, and the first character does not change, but here it looked like, so this is different. So this moved around a little bit, and this must have moved around. Why did it move around? It's we're yeah, this is a little surprising. I don't know if this is correct, because all we're doing is sorting things. We're now sorting by stroke count. Hmm. So so yeah, the reason why it's not really in an order we expect. This is so in a certain like cutoff region, like this one for example, these characters are not sorted by rank. But now we are sorting by rank, because once we've got the like clusters of characters with the same rank all at one spot, we're now sorting. We're also in that cluster. We're sorting by rank automatically. And in here, so before we had a this character. This character is now at a later position, and we'll probably find that this has a relatively lower rank, and has probably why. So 387. So in this characters cluster here, oh, so this is interesting, because it's actually it looks like this cluster is a conflation of several stroke counts. So if we look this up, this character has 12 strokes, and this one has oh, this one also has 12. And this 387, this one is moved later than this one. So I'm guessing this represents like a correction of ranking. 387 here, and Sumi, where is that character? It is having trouble finding it. Sumi 333 versus this one. What was this one? Oh, here we go. 333, and compare that to Mang, which means full. Mang 387. This is at line 1498. Sumi 333. 1899. No, these are very different. So it's sorting. So the thing is, yeah, these two have. That doesn't make sense. Let me. This one has how many strokes? Only 11. So this is in the previous kind of. This is prior to Mang here. Mang is down here. Okay, so these are only different by one stroke count. The thing is, Mang is down here, but really it ought to be up here. This ought to be the cutoff character for this cluster. So this ought to be up here. It ought to be sorted here, and it will be sorted automatically. And so this one kind of got bumped. This one got bumped down though. This got bumped down, so that doesn't explain it. So yeah, I may need to take a little bit more time to think about this, because this also was over there. And this was moved around a little bit. So right now I'm leaning toward this being correct, but I'm just having a hard time reasoning about it. I probably need to find the right mental model to actually think about this because it's not going that well right now. But in any case, I believe that these commits will not change much when I finally push them. I just need to do some consideration and thinking about whether or not this is all correct. And but for now, I'll end this video. So thank you for watching.